Welcome back. Let's talk about how we make urine and excrete it. The urine formation has three basic steps. That's it. Just three steps, and each step has two names. So learn the names of each step, learn where each step occurs, and learn what each step means and what happens in each step. So the first step is called glomerular filtration. The second step is called tubular reabsorption. In other words, we're sending stuff back from the tubules. And the third step is called tubular secretion. So the names don't sound quite like what they're doing. All right, so the first step, glomerular filtration. This means things that are in the blood of the glomerulus are leaving the blood and going into the glomerular space, okay? So in other words, stuff in the blood is leaving the blood, okay? What kind of stuff, you ask? Water, salts, waste products such as urea, uric acid, glucose, sugars, breakdown products like amino acids, not proteins, they're too big, but the amino acids themselves. So all of this stuff is leaving the glomerulus, going through all those little filtration slits, and now is in that glomerular space. And now it's called a filtrate. And from the glomerular space, it can then enter the proximal convoluted tubule. The stuff that's left in the glomerulus, the stuff that could not be filtered, is going to leave the glomerulus through the efferent arteriole. So glomerular filtration occurs 24/7, 365. Remember, you have 5.5 liters of blood in your body. Every day, there's about 180 liters of blood that gets filtered through this glomerulus and enters this space and becomes a filtrate, where I wrote the word filtrate. So it enters through the afferent arteriole and enters the glomerular space. When your heart's really pumping, it can get filtered at about 20 minutes, a little bit less than 20 minutes. But normally, your blood will be filtered 35, 40 times a day. So more than once an hour, all of your blood can be filtered. So your kidneys are working a lot. So this blood is going through the capillaries and through all those little filtration slits to become filters. So no large proteins, no cells, unless that glomerulus is damaged itself. So blood cells, all those white blood cells, all those red blood cells, all those platelets, all those plasma proteins to do with complement, to do with immune globulins, to do with blood clotting, all of those are going to be exiting via the efferent arteriole and not appearing in your urine. Second step, tubular reabsorption. So what does this mean? Reabsorbing, meaning going back. So remember, the filtrate left the glomerular space and went into the proximal convoluted tubule. So most of our tubular reabsorption is going to be leaving from the proximal convoluted tubule and going into peritubular capillaries, right up there in the renal cortex. We're going to have some things going by passive transport down concentration gradient, and other things are going to require active transports. Amino acids going to go across, some ions we need are going to go across, but let me talk about one thing in particular, and that is glucose. And glucose leaves in the proximal convoluted tubule. But how glucose leaves is interesting. Glucose needs a carrier protein, and glucose requires active transport. Now, normally there's tons of carrier proteins for normal glucose levels and slightly elevated glucose levels. But if you're diabetic and you have sky-high glucose levels, all of that glucose has entered your proximal convoluted tubule. You got this much glucose in your proximal convoluted tubule. Here's where normal glucose levels would be. Here's how much carrier protein you have. So only this much of your glucose is going to go back in your bloodstream. All this extra glucose is going to stay in your tubules. And it's going to have an osmotic pull. So all that water that would have passively gone back, a lot of it's going to stay in your tubules. So you're going to have a lot more urine volume than you would have. Yes, so you're going to get dehydrated. So you're going to be drinking a lot more water. So you're not peeing more because you're drinking more. You're drinking more because you're peeing more because your blood sugars are too high and you don't have enough carrier proteins. We only have enough carriers for normal and slightly high glucose levels. So, 2/3 of the water and sodium are going to be passively reabsorbed in the proximal convoluted tubule. So that still leaves us with 1/3 of each. And that goes into the loop of Henle, where we're still going to have some tubular reabsorption occurring. Sodium is going to be pumped active transport against its gradient, and so we've got all this sodium being active transport out, and then water is going to follow passively because water always follows where sodium is. Okay. And so now we have gotten rid of, like, 99% of our sodium in our water is gone back into our bloodstream. So that brings us to our third and final step, tubular secretion. So this is kind of like that last chance. It's stuff that's in the capillaries. And we want it in the tubules. We want it to show up in the urine. So it can go from the capillaries into the distal convoluted tubules as well as in the proximal convoluted tubules. Only certain ions and molecules. So yes, potassium and hydrogen ions, because this is going to be for buffering our pH. Also creatinine, a waste product. Penicillin, 90% of our penicillin is secreted in our tubules. And other medications, substances that were too large to be filtered in the glomerulus. This is their chance how they show up in the urine. But this requires active transport from the tubule cells to put it into the filtrate. So it's going to leave the blood, go into the tubule cells, and then it's going to require energy to actually show up into the filtrate. Okay. So this is the second method that allows substances to leave the blood to be added to the tubular fluid. Most 99% of substances that are going to show up in the filtrate are going to be filtered in the glomerulus through glomerular filtration. This is like the last chance workout thing. Also, don't forget that ADH and aldosterone can affect the filtrate when it's in the collecting duct by changing the amount of water that is being reabsorbed there. All right. So now we have urine. And what urine is what was left of the original filtrate. So it was a glomerular filtrate minus the tubular reabsorption plus the tubular secretion. And then minus whatever ADH and aldosterone did. That is what is now your urine, and that's what enters the renal pelvis to be excreted. Okay. So that's it for this part. Thank you so much for all your hard work. I'll see you when we come back and we talk about the regulatory functions of the kidney next.